Let's go over the homework problems from last time. There were two homework problems assigned. Let me do first 96. That was about geometric series. Unfortunately, the way the question was posed was very misleading. I apologize for that. It's some questions are nice in the book. This is a new textbook that we're using. Yeah. So let me quickly review what is a geometric series. So the geometric series. There are several ways of saying that. If you look at the general formula, it looks something like this. So where A is where the two values that are matter as A and R here, and so I remind you that if R is less than 1, then we have convergence, and if R is bigger than or equal to 1, then we have divergence. In fact, if we have convergence, we actually can give the formula for it. The value is then equal to this A over 1 minus R. Another way of thinking about geometric series is, let's start from 0 here. I said in geometric series, often easier to do it that way, is that there is a fixed way of multiplying the previous one with this fixed R here, which we call R is called the ratio. And if each time you get the next one by multiplying, and that's how you recognize this. Now, how does the number 96 formulate? They say that an divided by an plus 1 is equal to minus 10. Now, I guarantee you will never get it this way. You will always be told what the ratio is. But it is misleading. So remember, let's write down what I just said. It said that if I multiply the previous, so if I multiply an with r, I get the next one. Okay? So let's see what this quantity here is. To get that quantity, you have to divide both sides by n plus 1 here, an plus 1 here. So divide here by an plus 1, divide here by an plus 1. Right? So then we get 1 here. But now we want to isolate this thing, so we bring the r to the other side, so cross multiply, so we can an over n plus 1 is equal to 1 over r. As said, it's very misleading. I apologize for that. I must admit, I even made a mistake the first time I looked at it, because it's normally never posed that way. So what does this mean is that if this is minus 10, so what is r? Well, now you have to cross multiply. R is actually 1 over minus 10, or rather, minus 1/10. Okay? So that's the thing that you had to figure out here. Now, of course, once you figure it out, you just look at what it says here, right? The absolute value of r is now 1/10. That's less than 1, so we get convergence. And in fact, we know what the series is equal to, because A1, well, in their notation, they start with the index from 1, and therefore the first element is 1 over 10. So again, I apologize for the book using very confusing ways of stating things. What it meant was A is 1/10. But I guarantee you, the way you will get this information is either perhaps you have to find it yourself from whatever series you have, or you get it given to you like this. Okay, so the only thing that we need to do is plug it into this formula, and that is this 1 over 10 divided by 1 minus, now very careful, we have to plug in here r, not the absolute value of r, and we said r was minus 1/10, so minus 1/10, so that's a small little detail. And then if we have a compound fraction like this, the best way to get rid of that is to multiply with the common denominator, which is 10 here. So, but of course, it means multiply top and bottom with 10. And multiplying the bottom means every term in the bottom. So we would get these 10 cancels, we get 1. And then this distributes, so you get 10 plus 1. So you get 1 over 11. All right. That's the first problem on geometric series, but we will deal with geometric series more, and then you will see how we will use them. In that case, you will not have this weird way of asking the question. And the other thing that I was asked was about repeating decimals. Now, this is also going to be on a quiz. We have to catch up, guys, right? We have this midterm that we missed. I know this is new material, but it is very easy, and so I want to do our next quiz on that. Now, the next session is, because of the new recalibration period, is going to be, our first session, therefore, will be Thursday, April 2nd. Okay, so after today's lecture, this is the next time that we meet. That we don't meet on Tuesday. So that will be our quiz 2. And that will be on repeating decimals. And what I will ask you is to solve a problem like in the homework. So let me just go through the steps here. And there are perhaps different ways of solving this problem. But if you use a different way, you have to definitely show me every single step you use. But I would strongly suggest follow the steps that I am giving now. So I'll write it out a little bit in one. Step 1 is, well, first of all, we have to break it up in 2 parts, right? Because there's a part that is non-repetitive, and there's a part that is repetitive. So let's do this. So we have this part, that's the non-repetitive part, and then the repetitive part. Now, of course, we have to fill this up here with zeros then, right? So we get 0.00, and then we have 303, and this gets repeated. Let's focus on this one now. So step 2 basically is working out, because this is a geometric series. This is just something that's there, and we'll deal with it later. So let me give myself a little bit of space so that later on I can write down the solution over there. So I'm going to do step 2. I'm going to work out what is geometric series looks like. So as I said, it's something that. Let's break it down in parts, in its components here. So we have 303 plus. The next one now we have put 3 more zeros, right? So 0.00 and then 3 more zeros and then 303. Plus, okay, I'll do one more, but you don't have to do that. But just to show you what this means is the 2 more zeros, right? So we have 0, 0, 3, 3, and then we have 303. Now this is less telling. We should write it as fractions. 303, what do we have? Tens, 100,000, 10,000, 100,000. So we're talking about 303 over 100,000. Plus, what is this? 10, 100,000, 10,000, 100,000, a million, 10 million, 100 million. 303 over 100 million. Don't get scared by these numbers, right? 100 million, that's nothing. And so on. The whole deal is that we know that this is a geometric series, and remember what I said about geometric series is it's a fixed ratio that you multiply with, and here in this kind of things it's always something of the form 1 over, and this time it is 1 over 1,000. To go from here to there, you added 3 zeros. Why did you add 3 zeros? Well, because the length was 3, right, of your repetitive pattern. Okay, so R is 1,000, and that's all what we need to know, because we have our formula then. The formula is always this one, which is, of course, 1 over 1,000 is less than 1, so we know it's convergent. The only thing that we have to write down also is what is A. Well, A is what it is, the first element. Okay, so let's write so step 3, let's write out now what the fraction is. So this, well, let me just do it here with an arrow. So this thing is equal to A over 1 minus R. A is equal to 303 divided by 100,000 over 1 minus 1 divided by 1,000. You can put this on common denominator and work out this fraction. I find it easier, as I said last time in the previous exercise, multiply with the common denominator. So what is the highest power here? That is this one, right? 100,000. So multiply top and bottom with 100,000. Okay, so multiply. Of course, we have to distribute in the bottom. Don't forget there. Don't make silly things like that. And so these two cancel out. We have 303. And in the bottom, we have 100,000. That's this one. And then this one cancels out to be 1 minus 100. So we get 303 over 99,900. You see, I do this without really using calculator, but okay, if you feel a bit overwhelmed by the number of zeros, use your calculator. But yes, calculators are only limited, right? Things like this don't go well with calculators anymore if there are too many numbers. So, okay, but we are not completely done, because this is what I just calculated, this 303,990. But I also have to deal with this guy, and I have to write this as a fraction. Now, how do you make the fraction? Well, you move the decimal 2 spots, so 2 hundredths, right? Okay, and now you put this on common denominator. This is the common denominator, so I multiply top and bottom of this guy with, well, 999. Okay, so what do I get? twice 999, that is 9998 plus 303 over the common denominator. And then finally, let me give myself a little bit space here. This would end up to be 1022. No, wait a mistake. Sorry. Right? Yes. Okay. 2301 divided by 99,900. Sorry. This is, I put one too many. I got too enthusiastic here about my nines. Okay. So this is the final answer. And by the way, once you have your answer, it's extremely simple to see whether you're right or not. Because if you put this number in your calculator, I'm going to do it for myself here just so that I'm not telling you any lies. I get 0.02303. But even if you are off with one decimal, if instead of a 1 you would have a 2 here, you get a totally different number. So that's, in other words, I shouldn't say a totally different number. What I mean to say is you get a totally different pattern. And so that's why you easily can see what your mistake have. So I just did that, and the pattern became 304. So you see many digits are different then. So this is always easy to check. But when you do this, I have to see all the steps. Or if you use a different method, all the steps that involve that method. If you just give me this answer, I'm not going to give you much credit for it. All right? So that's for the quiz and also for the homework problem.